Hey folks, what I'm going to talk to you about today is what security and SRE want. It's like 90% the same, okay? And what I am also going to talk to you about is how you can use your relationship with the security team for fun and profit. So, hi, I'm Lea Kissner. My pronouns are they, them. I'm not an SRE. I'm a big fan of SRE, so I am very honored to speak for you today. What I am is a security, privacy, trust and safety. If it's terrible and happens on the internet, then I've probably worked on it. I was at Google for over a decade, started out by doing an awful lot of the infrastructure security, and I ended up as the global lead of privacy technology, so did a lot of things in between. If anybody's run into Zanzibar, which is Google's access control system, it's a public thing now, that was my baby. I went in to help Zoom. Remember in 2020, they had all those terrible problems. I got brought in to go sort them out. And I was the CISO of Twitter until the drama descended. And yeah, now I'm not there anymore. I am the CISO of Lacework. We do cloud security because holy crow, is the lack of security a real problem in the world. So my PhD is in cryptography, which means that by training, I am in fact a giant math geek. When I landed at Google, I had two projects. One was logs anonymization, which was up my alley. And the other one is a thing that was called LOAS. This is Google's low overhead authentication system. Now we would call it a service mesh. But you know what? Back in 2007, there was not a name for service mesh. This was a thing we were very much making up as we go. And what it does is the authentication between all the little things that are running in Google production, and it does the encryption, it does things. And it turned out that it came in two modes when I tried to roll it out. One of them was crash the entire distributed file service. Yeah, and the other one was make Google search serve 500s. And these are bad modes for your service mesh. So I got to scoop out the guts of the RPC system and rewrite it. And that's how I learned C++ and multi-threaded programming and networking. And most of you are probably now cringing so hard that you are about to fall out of your chairs. And okay, I violently agree. I'm not sure who thought it was a good idea to let me do this, but I will reassure you, this was like 2007, Google still exists, I didn't actually break everything. And why did I not break things? Because I didn't do it alone. I worked with an incredibly talented group of SREs who were really good about answering my questions and running the rollouts and causing things not to terminally explode. The thing that I didn't realize for a while is that they weren't just there because I was a well-intentioned but extremely real menace. They were there because SRE wanted the same thing that security wanted, right? So security, we were like, well, we're security and we're paranoid about incidents, and so we don't like people messing with things they're not supposed to mess with, and so I don't like it when people touch those things. And you know what? SRE, you're paranoid about incidents. You don't like it when things break, so you don't like it when people are poking their fingers in and touching things that they're not supposed to touch. And hypothetically, Google might have had a teensy little problem where an intern ran a large MapReduce computation and a little teeny bit took down all of search. And hypothetically, nobody wanted to do that again. So we wanted the same thing, right? And the more work that I did with SRE teams, the more I noticed that what security and SRE want is, like, it's 90% the same thing. I have built myself a theory as to why this is the case and why this tendency grows with the size of the system. And this is called the law of large annoying numbers. Okay, any system has random behavior in it, right? Even if your software is perfectly stable, and if you work somewhere where the software is perfectly stable, I am shocked, because I don't think you'd be at this conference. I also don't think that your software is not changing really fast, so it's not really perfectly understood. But even if that were the case, hardware failures are randomized. And so you're going to have random behavior in your system. So for example, a couple years back, actual cosmic ray hit an actual system and terminally broke a thing called a certificate transparency tree, which is this really important internet security thing that, to take an unfortunately real example, doesn't let China Telecom sign SSL certs, letting people pretend to be google.com anymore. And that random behavior that we're seeing through all of it, it scales up with the size of the system, right? So any sufficiently large system contains so much random behavior that it effectively acts malicious. So for example, Gmail's real large, right? Even 15 years ago, it was so large that they ran into a hash collision in the system that was trying to deduplicate some stuff. That's usually a security problem. That's the sort of thing that I worry about. So we end up in a situation where the security team is trying to protect against malicious behavior, and the SRE team is trying to protect against there being so much behavior that it effectively acts malicious. And you know what? If we work together, we can be that extremely specialized kind of lazy, which is planning ahead to avoid surprises. Because you know what? In SRE and security, we all hate surprises. There is not good surprise in our world, right? And we can avoid building two systems when one would work just fine. Thank you very much. So there are a whole bunch of things that we want in our systems that are the same. For one, like I said, access controls. We do not like it when people touch the things that they're not supposed to be touching. In SRE world, we also call these dependency control systems. I have gotten so much mileage out of showing up to an SRE team and saying, would you like a dependency control system? Because you can have one for the low, low price of helping me roll out this access control system. And not enough people have figured out that really fundamentally these are the same things. This includes security people. Security people do not get off the hook on this. I have seen security people try to roll out systems where they say, well, I'm going to grant access on the granularity of data type. So you get access to the user IDs. You get access to the user IDs in the backups. You get access to the user IDs in the serving system. You get access to user IDs in some weird copy that somebody made of the production database so that they can do some debugging. You get access to the analytics system. It doesn't solve, I don't think it solves the security or privacy issues, mind you, but it also doesn't solve any of SRE's problems. Network design. We don't like people accessing things they're not supposed to. We do not like people whacking on the servers that they're not supposed to. So things like DOS attacks, both from outside and from inside your services when they don't have the retry behavior dialed in, and then you start hitting one piece of your service against each other, and everything's sad. Also, Amazon charges an astonishingly large amount of money for NAT gateways. And if you run your own proxy like Envoy, you get egress controls. And those are amazing. Security loves them because then you don't have your malware trying to talk to its command and control server. And both security and SRE tend to love these because people are not downloading random code from the internet and running it in production and causing everything to get a little bit weird. Also, you get back money, which you can spend on other things, which everybody loves. Observability. We are both trying to detect incidents, albeit often different types of incidents. So tracking an attacker is a little bit different than debugging, but the information that you need for each of these overlaps really, really heavily, like traffic flow and tracing. So give your security buddies access to your logs. If they don't have it already, they'll probably be really excited and really want to help improve your systems. I love giving my SRE buddies access to the security logs because, hey, now they're really interested in making sure that those are complete. And a lot of times you can merge some of these functions. When I was at Twitter for a while, a lot of the observability functions ended up rolling up to my org. Why? I don't know, we cared a lot about it and somebody needed to take care of it, so they ended up in my team for a while. Releases. Okay, patching. We all love predictable patching. I love not getting owned, but I also like being able to debug things well, right? There's a reason why you call them cattle, not pets. Having this whole mess of slow and partial patching is just a total headache for everybody involved. Good release engineering. Fast, safe releases are how you fix incidents fast. Release speed is a security feature. And I realize that not all the security people have figured this out yet. I have an article that I wrote about this that you can pass to your security team if you want to get them to like start letting you release faster. I will talk to your CISO about it. I know it's important. Actually, back when I was running security and privacy for social products at Google in the early 2010s, there was a critical bug in the TLS SSL protocol, and every single client needed an urgent update to all of that code. I was really lucky to be working with teams that had figured out how to release really, really quickly, and we released really, really frequently, so it was fine. We got all of ours out globally within a couple of hours, all of those patches, modulo the iOS App Store stuff. The rest of Google was on the same infrastructure, and the only difference was that they didn't release more than once every month or 2 months. They took 5 weeks to get those critical security patches out, right? That was the only difference. And how do you make those releases safer? Testing. There's all the normal reasons to test. You should test pre-release, but there are things you can't catch except for when you hit the real system. There was an extremely memorable time where somebody changed a protocol buffer definition and renumbered something. And for those of you who haven't done a thing with the protocol buffer, don't do this. Because what happens is your client and your server roll out at different times, and your client starts telling your server one thing, and the server hears something entirely different. And the thing that happened, it's the sort of thing that you call somebody like me for. And the reason why I know about this and you don't, the only reason that this is the case is because the person who wrote that code was testing for a bunch of impossible conditions and made the server scream as soon as this happened. Feature flags, right? When something goes wrong like that and you need to turn something off, boy, is it really nice to not have to take down the entire service. Like bonus things. Putting everything in its place, right? No ClickOps. ClickOps are bad. Put everything in Terraform. We want to know what everything that's running in prod and for all of those things to make sense. And this one, I was really surprised. One of my SRE buddies asked me to put this in the talk. Data taxonomies for every application. And I was like, really? Because usually I'm the one who builds that because I need it for privacy reasons. And then SRE uses it, but I didn't realize that he wanted it so much because he says he's paranoid every time he's looking at a service or a data store that he wants to understand what he's looking at, which having been the one who ran the Street View Wi-Fi incident, yeah, data you don't know what it is can really hurt you. But he's really worried not just about knowing what types of the data it is, but what all of the constraints are so he doesn't cause a major headache down the road. And he wants to know the criticality of the service. And I was like, that's great. We both want that. Incident response, right? After I touched the RPC service at Google, I ended up maintaining it in my copious free time because Google didn't always staff things that everybody used for some reason. So I have worked more than my share of production incidents as well as security incidents. So I'm going to go ahead and say this is mostly the same. Incident coordinator, blameless postmortems, everything. The process should be pretty much the same. It often hits the same folks. Security, we do have more lawyers hanging out with us, but pretty much the same. And eliminating toil, right? We both have more than enough to do, thank you very much. And we cannot do our jobs if everything is artisanally crafted. We won't be able to see what's going on through all the noise. We can't move fast in an incident. And all of this stuff is stuff that you're just gonna see in any SRE conversation, right? But it's stuff that we have in common, and it's stuff that we both want, which we can take advantage of. Another thing that we have in common is that when perverse metrics happen, especially in the product teams, we're the ones who get hit. A metric is a quantifiable metric used to figure out whether you're doing well or not at a particular thing. So that's what I would call a goal metric, measuring whether you're meeting your goal. This is separate from a program metric, which measures whether progress is being made on your work. So, for example, If you want to make it faster to complete a task, you might want to measure the time it takes from the beginning of the task to the end. And that sounds pretty straightforward, and it is, but you also need to think about things like, is it wall clock time? Is it elapsed time? What kind of time are you talking about? What about people who don't complete the task, right? It gets a little bit complicated, but generally a good metric. A perverse metric, on the other hand, is a number that doesn't tell you what you think it's telling you, so then you make really bad decisions. We are not capable of working with the complexity of the entire world as it exists and it changes. We do not have the input-output capacity in our squishy human meat brains, and we definitely don't have the working memory. And we have all kinds of heuristics and implicit biases that make us overlook the unexpected. A lot of us avoid bad news. I mean, fewer people in this room, because we're all cheerful pessimists mostly, but that's something that tends to really, really bite folks. And metrics can lead you horribly, horribly astray. Let me give you an actual, honest-to-goodness, real answer, a real example of an actual, real company-level metric that somebody actually used, which was send in notifications this quarter for a staggeringly large number n. And you know what? I can make that happen tomorrow. No problem. Whoever set that metric is going to hate their life, though, because I'm going to use it as an object lesson to make sure that they never do it again by sending all of the notifications directly to their phone, right? And I think that these sort of metrics hit us really hard because we are risk-oriented disciplines in a lot of ways. And so, for example, usage numbers. Product people are like, I love to see that my product has more and more usage, which is great, but it could be that your system isn't retrying effectively, and so you're whacking an interface really hard. It could be a DDoS attack. Neither of these things are good, but they make the metric go up, and that's inherently a metric created by somebody who believes that things happening is good. As a side note, this shows up a huge amount in trust and safety as well. So for example, harassment. Harassment is a bad product experience. But people will engage in harassment very enthusiastically. So if you want your product numbers to go up, harassment turns out to work really, really well. So given all of that, why are SRE and security not the exact same thing? Why do we even have two different teams? So I'm just going to go through a couple of them, but one of them is error budgets. SRE, you usually have an error budget which is not 0. Security does not. One security error is still a security incident. So one of the places this crops up really often is tiny little experimental launches. A tiny experimental vulnerability is still a vulnerability, and when you roll it back, most of the time for SRE, everything's fine. But a lot of times for security, you're like, oh no, I still have a hacker in the system. Like, I'm still in a bad state. So SRE tends to be a lot less twitchy about tiny little launches than security is. We are not as good at measuring. We aspire to your level. And I say this working as a company that does security measurement. A lot of what we're trying to measure is actively hiding from us, and we almost never get ground truth to work with, so this continues to really be a challenge. Compliance. Most engineers hate compliance, probably both because it's inflexible and it sometimes seems kind of useless. And you know, hey, I'm going to agree with you, okay? A lot of the bits in these frameworks are aimed at companies that are not the kind that has an SRE team, and so frankly, those bits are not going to help you build a better system. Right now, we are deep into dealing with FedRAMP, and some parts of it made me very grumpy. For example, we have to use FIPS-approved cryptographic implementations. And this is a throwback to the 90s when cryptography came in a box, and you would ship the box to the testing lab, and they would test the box. And this made a lot of sense because back in the 90s, most cryptography was bad. Even in the early 2000s, most cryptography was really bad. I was a grad school and I had a standing offer that I would break people's terrible cryptography in exchange for pizza. And a lot of the companies that were sending me this stuff, they wouldn't even buy the pizza. Like, that's how bad they were and what they were working with. but this can actually make you less secure. So real story, back when I was at Zoom in 2020 sorting that thing out, there were there was one high severity vulnerability in OpenSSL. And so we patched it really quickly everywhere, except for the FedRAMP cluster. We were literally not allowed to patch the FedRAMP cluster because you have to have a approved cryptographic implementation. So you take your code and you ship it to the testing lab and say, please check my implementation, which is not great because they took a couple of days to do that. There are also a number of other things that make me sad about this, but you know, I have notes. A lot of them are about elliptic curves. Some of them are about the end-to-end encryption protocol for Zoom. I have stories about that if you want to hear them. But some parts of FedRAMP are frankly a really good idea. There is a thing in there that says it wasn't before, that says you must use phishing-resistant two-factor authentication. Great. Everyone should have this, right? We should not be having a discussion about whether this is a thing that we should have or not. You should have YubiKeys. You should have the hardware in your laptop that does FIDO. But it turns out that even when there are goofy bits, you kind of have to do compliance anyways, usually for at least one of two reasons. One, people will give you money for doing it, and you can exchange money for goods and services, which means it's very handy to have. The other one is that governments will get very grumpy at you if you don't do it. And then it turns out when governments are grumpy at you, and I can say this as somebody who's had to deal with a lot of regulators in my career, this is not good for your ability to continue having a product or a business. So I would suggest that this is a thing that we should do. So it's a little different, but you know what? It was 90% the same things, right? So given all of that, how do we work together? First off, I would suggest that the thing we should be aiming for is respect. That is regard for the feelings, wishes, rights, or traditions of others. People are different. Companies are different. This is a feature, not a bug. And if we're going to do a good job at providing good systems, and that means SRE, that means security, that means trust and safety, that means privacy, we need to be solving problems for actual people. Otherwise, we're not actually solving problems. Messing with respect also tends to line up quite nicely with a combination of things that many executives find very motivating, like product experience, right? People who build products tend to care a lot about the experience. And it turns out that there's a few things that are respect that they care. So for example, harassment is a bad product experience. You should probably do something about that. Getting hacked is a bad product experience. Losing somebody's baby photos is a bad product experience. I've even had to explain to people, sadly, often, CSAM is a bad product experience, child sexual abuse material, and also people who engage in it are bad customers and they are going to mess up your day in other ways, like they use fake credit cards. They will make your product the cesspool of the internet. Please kick them off. Also, speaking of which, things lawyers that are involved in. Things that lawyers are involved in. Executives tend not to like that happening because while we appreciate our lawyer coworkers, and I've worked with a lot of amazing ones, usually if a lot of them are involved in something, it's not going well. Breaking the promises in your contracts, like availability, really expensive. But you know what's really expensive? When regulators go after you and you see these big fines that show up, here's the thing I can tell you from having worked on a lot of those things, the fines aren't the expensive part. The fines are the cheap part. The things that's expensive is all of your lawyers and all of your compliance firms and the fact that you have to change your business practices and you have to change your systems and you actually get restrictions on what you can do in the future that other companies in your field don't have. Ends up being a real problem on top of the massive hit to your company's reputation. And then there are also things that you look like a jerk or an idiot for doing. Executives don't like looking like jerks and idiots. Although I will note that I will take looking like an idiot any day over looking like a jerk. So for example, if we get hacked by this particular vulnerability, not only this is a bad product experience and we will probably have a lot of lawyers involved, we're gonna look stupid. So like maybe we should patch this. Also, many AI and ML issues fall into this category. You really want to look like an idiot over a jerk, but you're probably going to look like one or the other. And all of these failures are things that at least one of SRE, security, privacy, trust, and safety care about, although I would argue that all of us should be caring about all of them. Sorry. But also, if we use respect, that gives us a really good North Star to aim for, right? When we can say things like, we want to keep our promises, right? We made promises to our users, to our regulators. It is very important for us to keep those. And that actually overlaps really heavily with compliance, but you probably look at that and go, oh, that's a thing that I understand why I should care about it. That's the thing I actually care about. That's why we should be doing it. Respectful product experience. And it also really key. And a key part to doing that is getting all of those things in our overlapping systems. And that's just something we do better together. We're more powerful together. We have different levers, and we can combine them to be very persuasive. So you know yours, but like I can personally vouch that executives do not want to go to jail. And you know what? I have gone to a surprising number of meetings where I say, one of the goals of this project is that no one goes to jail. And everybody's like, yes, that is definitely the good goal of this project. So one of the ways that this worked at somewhere like Twitter or Lacework is that SRE usually has a bunch of projects where you're like, I really want to clean this up. You know what? I get to show up and say like, hey, would you like me to raise the priority of your project like a lot? So for example, actually at Lacework, we had SREs wanting to do network redesign. And I was like, great, we're going to call this egress protection now. And now it's a very high priority. And they were like, yeah, right? Same sort of thing happened at Twitter all the time, where I could show up and like, and we could be like, with our priorities combined, we're gonna, that's not a slide I wanted. There we go. Okay, with our powers combined. And here's the thing, I'm gonna have to apologize on the behalf of a lot of security teams. A lot of security folks have not figured this out yet. And so if your security team has not figured this out, go to your CISO, become best buddies. You're gonna have to do some translation, okay? So I found out a lot of this when I was looking for a job a little over a year ago. Most CISOs are not engineers. They're not security engineers. They're not SREs, they're not any kind of engineer. I am one of the few CISOs who has a computer science degree. There are even fewer of us who have been security engineers or software engineers of any stripe. I am, according to the recruiter firms who work on CISO searches, probably the only one with a PhD in the area, okay? You're gonna have to do a little bit of translation, but if you show up with that list, or if you go look at their priorities and you go figure out what's in that list that you want, show up and ask them. Go talk to the GRC team. GRC means governance, risk, and compliance. If you haven't talked to them yet, they have these huge spreadsheets. And their huge spreadsheets are full of completely unreadable language that says, you will control something, ingress, blah, 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 right? They're huge. And they're trying to translate those into some kind of language that somebody who has actually touched a system before can use. If you go and sit down with them and you say, explain to me what this means. A lot of the times, the things that compliance are asking you to do, they're much more flexible than they look like. And you can sit down with them and be like, oh, we could just make the system work better and we're gonna get this. And they're gonna be so excited because they spend a huge amount of their time trying to get anybody who's an engineer to talk to them more than the absolute minimum amount. Okay? You can use this and it will make everybody's life so much better. And your CISO, one of the things that your CISO is probably the most scared about is going to jail. And I'm 1,000,000% not kidding about this, okay? We do not want to go to jail. I was personally go to jail liable for Elon Musk for 2 weeks minus 12 hours. I don't work there anymore. They almost sent Joe Sullivan from Uber to jail. They are currently trying to send Tim Brown from SolarWinds to jail. There are more cases out there. And all of this is very undefined. Like, it's super, super undefined. And right now, CISOs are terrified that we're going to go to jail, even if we're working really hard and we're making things better. So your CISO is extremely motivated to get things into a place that you're not going to get hacked, that you're not going to have bad things happen. Okay? So go use that. Go make better systems. Build respectful stuff. Thank you very much.